All right, we are on day 2 of proving our trig identities, and reminder that all of these, our big focus again is going to be showing our work to support the proof part of it. They tell us what the answer is, we show that that's correct. So a reminder, show all your steps clearly, only do one step at a time. We are done when the right hand side equals the left hand side. Does not matter which side you work with. Strategies, I would pick the more complex side, work to match the easier side. If you get stuck, try going to sines and cosines. Typically more easy to go from something that is separated to a single fraction than to separate fractions, but we can do it. I can show you how. Look to factor. That is something we haven't done a lot of. We'll look at one like that today. And just try something, start somewhere, try something, and go from there. Sometimes that'll lead to something, sometimes you have to start over, trial and error. So on our first one here, let's see, I need to get a pen. All right, it gives us sine of x over cosine of x plus cosine of x over 1 plus sine of x equals secant x. And obviously the more complex side is going to be the left-hand side. What we would want to do is get a common denominator. And we're going to look at this one twice because I think there are kind of two different ways we could get a common denominator. One of those is to just make our common denominator. Let me make this a little bit thinner here. Make our common denominator all of every denominator. So we would have a cosine of x, we would have a 1 plus sine of x, and I go up and I then look at what is missing from the common denominator, and on the first one you can see we're missing the 1 plus sine of x, so we're basically multiplying by the other denominator. And I would go ahead and distribute that. So as I distribute here, I'd have sine times 1 is sine of x, sine times sine is sine squared. And our second fraction is missing the cosine of x. And so cosine times cosine gives me a cosine squared. And now I have a common denominator and can add straight across the top, straight across the bottom. Keep that common denominator. And in the top, what we can see is we've got that squared with a plus or minus, and anytime we see a squared with a plus or minus, we want to look for our Pythagorean identity, and there is our basic one, sine squared plus cosine squared, and that equals 1. And so what our numerator becomes is sine of x plus 1 over and that sine of x plus 1 in the top and sine of x plus 1 in the bottom, we can simplify out of there, leaving me with 1 in the top and a cosine x in the bottom, and 1 over cosine x is secant x, which matches what we were trying to prove. I do want to look at this one a second way. So if we were to look at this as a second option here, starting again at the beginning, we could have gotten a common denominator slightly differently, and I just want to show you a second option here. One of the other things we could do is turn those both into a cosine squared, and I might not work the whole problem here, but you could turn both of these into a cosine squared, again, slightly differently. To do so our common denominator is going to end up being cosine squared. We would run through, first of all, obviously multiplying this first one by cosine x. But the second one, in order to get that to be a cosine squared, we could have multiplied by the Pythagorean, or using our Pythagorean identity, 1 minus sine squared is cosine squared. And to get that 1 minus sine squared, we would have multiplied by the conjugate, 1 minus sine x. 1 minus sine x times 1 plus sine x would give us 1 minus sine squared, which is where that cosine squared is coming from. And in the top, I would distribute through cosine x minus cosine x sine x. And so now we've got that cosine squared in our denominator. And then looking across our numerator, cosine x, sine x, I'll write all that out. And what you see is we've got like terms cosine sine, and we've got a cosine sine minus cosine sine. Well, those would cancel, leaving us with just a cosine x over cosine squared x. And again, we've got a cosine in the top and 2 of them in the bottom, so I'd be able to simplify there, leaving me with 1 over cosine x, which again equals secant x. And so it just gives you a second option, so reminding you that there's more than one way to work each of these problems. So again, as long as we're following legal maneuvers as we do this, more than one way that these can be accomplished. All right, looking at our second one, again, how do I pick the more complex side as I look at this? I may choose the right-hand side on this one because, first of all, they're in terms of secant and tangent, that they are separated, and so what I could do is get a common denominator and make that into one fraction. But what I want to show you when we do that, so I'm going to work with the right-hand side here. I'm going to start by turning these into sines and cosines. They already have a common denominator, and so I get to 1 plus sine x over cosine x, and we kind of run into a little bit of an issue here, is that I'm trying to get it to be a cosine on the top and a sine on the bottom, and it's not looking that way right now. So a couple different ways we could attack this. One of the things we could do is, I know that I can turn the 1 plus sine x into a cosine squared if I were to multiply this by its conjugate 1 minus sine x, and that would get me a cosine on the top, which again, if I multiply the top, I have to multiply the bottom. Okay, so 1 plus sine x times 1 minus sine x is going to give me that 1 minus sine squared. And 1 minus sine squared is the same thing as cosine squared. And then we're able to simplify here. I've got a cosine in the top and a cosine in the bottom that I can simplify it out of there, leaving me with just a cosine in the top and a 1 minus sine x in the bottom, which is actually what we were trying to prove. So we would stop there. You could have worked with the other side as well, and what I would have done on that one is try to get that one separated into 2 fractions. I would again probably have used our conjugate option here. So if we just pick, let's go a different color here. So maybe we had gone with the right hand or left hand side. Let's make that a little skinnier. Again, I probably would have worked with our conjugate, 1 plus sine of x. I'm trying to get it to be secant plus tangent. You'll notice that a lot of times on the distributing part of it, I hold off for just a few minutes to see what's going to happen before I distribute. And that is because of this next step. A lot of times what happens is it'll end up canceling. 1 minus sine squared is cosine squared, and the cosine here and one of the cosines here would cancel. And we get to 1 plus sine x over cosine x. And I just want to show you an option here is we really can, because we want this to be two separate terms, break these into the two fractions right here at the plus sign, both over, give them the common denominator of cosine of x. So I'd have a 1 over cosine of x, and then a sine of x over cosine of x, giving them both terms in the numerator that common denominator. And then we can turn them into their identities. 1 over cosine x is secant x, and sine over cosine is tangent x. And the reason I chose to do that is because that is what we were trying to make them match. So that would be a second way of proving that one. And let me make this full screen so you guys can see everything. There we go. So then you can see everything side by side. Again, two options here of how to attack this, one working with the right hand side, one working with the left hand side. I probably would have picked the right hand side on this one because it's easier to put things together, but that one needed a little trick that we hadn't seen before. So all right, your assignment then is not that. Your assignment is to do worksheet B, and on worksheet B, do the problems that are assigned, which I believe, double check me on this, is one, I'll have to check, follow what's written next to the worksheet.